Okay, hello class. This is just going to be a short video explaining overloading of functions. We've already covered functions to some extent, and this is just a little piece that we didn't have time for before the midterm. So overloading functions is a component of C++ called polymorphism, and which is a fancy word for meaning many forms. And what we are going to do with it in C++ in this example is it lets the programmer use one program function with multiple, well, it's the same name with multiple functions. The compiler chooses what implementation to use based on the arguments provided in the call. So functions can be overloaded to handle different types of data and different numbers of parameters, but they share the same name. So briefly, overloading means two or more functions share the same name, but their parameters are different. In this situation, the functions that share the same name are said to be overloaded, and the process is called function overloading. The number and types of a function's parameters are called the function signature, and together, the function's name and the signature uniquely identify it. So let's take a look at a couple examples of this. And these are on Blackboard in a zip folder that you can download and run live so you can see them and play around with them, changing them around. So what I have here is an example of a function definition, and I didn't use prototype statements in this case because the functions were so short. But anyways, I have one called print, and in this case, the parameter that the function requires in order to work is to have an integer sent to it. And when it receives that integer, it executes this cout statement that simply says printing int and then telling me what the I that was sent to it was. Now here's an example of polymorphism. I've created another version of the same function called print. Notice I'm using the same name. Both of the functions are void function, so the return type is the same. But what really makes it possible to create a polymorphic example here is that in this case, the second case, print is requiring a double to be sent to it. And then in the third example, I have, again, used print, the function print, and I'm requiring that a char or a character be sent to it. Down in the main program, all I'm doing is calling the function print 3 different times. Once by sending a 5 to it, the second time by sending a decimal value, and the third time by sending a character to it. So again, each of the calls are to the same function, and the compiler does the job of figuring out which function is actually going to be needed for a particular call based on the argument that has been loaded in to send to the function. Okay, so let me go ahead and run this and we'll see the result of this. All right, so what we have is we have printing int 5, printing float 501.75, and printing char or character h. And so what we see then is the evidence of the polymorphism where it called, when I passed the 5, it called this function which requires an integer and prints out the word printing int. And then in this example down here, we're passing a double, so the compiler told the computer to run this function because it's passing a double. And then the third final example, it's passing an h, so we're calling this function in order to print out the char. So again, this is an example of function overloading. The function in this case being overloaded is the function called print, and the way I'm overloading it is that I have 3 different signatures for the function print. One that requires an integer, one that requires a double or a floating point value, and the third one requiring a char or a character. So let me show you another example. In this example, what I'm doing is I've created, well, first I'm using prototype statements in this example. So I have the prototypes that precede the main program, and then the function definitions are down below. So I have for example, a function called add. It's a void function, meaning it's not going to return any value, and it requires, in order to work, two integer values to be sent to it. And when it receives the integers, it outputs this line of code, which adds I and j together, and so that's where the values are being added together. And then we have in the overloading polymorphic example here, we have created another version of the add function. This time it requires an integer for the first value, but a double for the second value. So its signature is different from the first add definition. And then the third one, we're looking for 3 integers to be sent. So again, we have 3 different versions of the same function called add. And then if we go up to the main program, we can take a look at how we're calling those functions. So first we're declaring a set of integers a, b, and c, which are equal to 1, 2, and 3, and a double called d that is equal to 1.1. And then we have the 3 functions that are calling and passing data. The first time we call the function, we're passing 2 integers, that's a and b. The second time we call the function add, we're sending a integer and a decimal value. And then in the third example, we're sending 3 integers. So this demonstrates the 3 examples of polymorphism that we have for this program. Let me go ahead and compile and run it. And what we get is our output is a result of 3. That's when we sent the 1 and the 2, which are the 2 integers. So we output this example here. So this was the function that was called when we passed the 1 and the 2. And then we have an output of 3.1. That was when we passed the integer and the double being 1.1, the integer being 1. And then the third example, we're passing 3 integer values, 1, 2, and 3, and we're adding those together. So here's an example of polymorphism where we overloaded the add function, but did it in a way that had different data types and a different number of data types. All right, and then we'll take a look at the last example. And in this example, we're using polymorphism. Again, I'm using prototypes to declare the functions ahead of the main program, and then here's the definitions of the 2 functions. Notice that we're passing data by reference, which means that we're passing an address to the function, and then in this case num, which is the variable that's being used locally in the function, is going to have a 2-way communications between the variable a and the variable num. So a and num are both going to be pointing at the same value once the data is passed, the a is passed to the function. So we have 2 examples of, or polymorphic examples of times 2. One that requires a single integer to be passed, and the second one is passing a double. And so the difference in the 2 as far as the signature is one requires a integer whole number and the second one requires a double or a decimal value. I'm going to go ahead and run the code. All right, and here's the result. So I've got a equal to 8 is doubled to equal 16. B equal to 5.25 is doubled to equal 10.5. And you can see in our main program how we accomplished the polymorphism. First, we declared a couple of variables. A is an integer. We declare it to be equal to 8. And we declare B as a double and assign it 5.25. We're calling the function times 2, passing the integer. When that happens, this function is going to be executed. And then the second time we call the function times 2, we're sending B, which is a double or a decimal value, and it'll be executed by this function down here. So again, this is an example of polymorphism, in this case of overloading the function called times 2 with two different data types, one an integer and the other requiring a double. So hopefully this concept of overloading and what it means to be polymorphic in your code makes sense. Now, these are very simple examples, so the significance of what polymorphism means in C++ is probably lost on you right now, but you'll see more examples of it as we go forward. So the only thing I need you to do now is do the assignment that is on Blackboard. This is homework number 4. It'll be due next Tuesday at midnight. Thank you.